So that's why before moving the analysis part, let's know what we have, the scenario or the tabs, okay, which means the basement thing. So that's why today's class has been arranged, that is introduction to open VSP analysis part. Okay, before moving to analysis, let's know what options we have in the open VSP so that we can do our analysis part successfully without getting any trouble in the open VSP software. So analysis is the process of taking the discretized element, or we can break our geometrical element into small uh, elements, right? Okay, smaller parts, because to get a better understanding about each and every element, and at the end to achieve uh, good result, right? So that's why we'll do meshing and all, right? So that same thing can be done in the open VSP. Okay, so we will go to open VSP software to complete our today's topic. Okay, so we'll be focusing on our model. Okay, whether what model I have designed. Okay, that model, how the performance will be given that X model which you have designed. Okay, or what will be the aerodynamic airflow, or what will be the other aerodynamic parameters or aerofoil parameter, okay, which will be encountering and which will be giving any kind of result or analysis part of your model. Okay, so which means for any model, the next step, what we'll do the analysis by using our ANSYS software, or we will even use hypermesh software for discretizing the elements. Okay, that's like a high fidelity software. So like conceptual stage or ground level stage, just to analyze your model roughly, or to get some practical scenario. So for that case, for short time period or to consume your time, this is a very good software. Okay, where you can even complete your model by using the dimensional parameters, okay, 2D, or your sketch what you have. By using that sketch or by using geometrical parameters, you will be designing your model. Okay, and after that same model you can even have a rough analysis in the open VSP. Okay, which means some predictions you can give with respect to your models. So that's why we have this tab. As we know, in the file we have done with all these menus. Under file what we have, under edit, this also done, window, view, model, right? And we are here now, analysis part. In this analysis part, we have first menu bar, that is compound geometry, planar slice, mass proportion, projected area, surface interaction, CFD mesh, FEE mesh, degenerate geometry, okay, VSP arrow, wave drag, parasitic drag. Okay, what all this menu tells us that you can compute your geometry. Okay, you can even take a planar slice. Okay, mass proportion kind of work, that kind of analysis, and projected area also you can find. Okay, like if you have designed any fuselage model in the same VSP software, or if you have done your 3D wing, then what is the projected area that you can get in the analysis part. And surface interaction, CFD mesh, computational fluid mesh also can be done. FEA, finite element analysis mesh, okay, and the generation geometry. This is with respect to the geometry to generate the degenerations, okay, and VSP arrow. In this VSP arrow, okay, we have many parameters like if you have designed or after design, if you've done analysis, whether that may be CFD or FEA, okay, suppose you have done CFD mesh, okay, then now you want to get two parameters, okay, like for your fuselage, not fuselage, let's take a simple geometry or simple structure like what we have, or aerofoil, okay. So for aerofoil, if you want to know the drag or lift component, okay, or movement coefficient, okay, so like that, what parameter we have, okay, not only for our aerofoil, even though for complete wing we can generate those parameters, and we can have a practical kind of results in this VSP aero, okay, where we will get all our parameters, okay, like CD naught, CL, CM, moment coefficient, okay. So once we launch our solver, it will give when we'll do that analysis part, that time I will tell clearly about this. Today is just an introduction class, just I want to give introduction about all this, okay. And see, in this wave drag, you'll get the information about wave drag and parasitic drag, okay. So in this compute geometry, we have to take any text file. If you have, you can take that text file in the sense, suppose you want to run your script, okay, like some programming script if you have wrote, okay, that script you can select and you can run. If you have file which is like a .csv, that also you can select and you can run, or .tsv file, okay, for parasitic drag output, okay. uh, if like that kind of programming if you have done, okay, computational programming kind of programs if you have typed, okay, for your model, then same file you can select and you can run that script file, okay. That may be text format or csv format or tsv format, okay. File you can export, and here we have the setup. Oh, this is not required. So like just to select the half mesh, okay, it's like a checkbox. If you on, then it will work. If you off, it will not work, okay. This is about exporting the file, okay. We can export your file, and here we have planar slice. Suppose you want to take a normal axis along x, y, or z, and number of slice you can type, and you can start doing that slicing, okay, for your model. It will affect, and the output file. So once we'll do all these operations for our model, then you will understand. Just get that information, or understand that by using this menu bar we can get number of slicing, planar slicing, okay. Just you have to type and you have to start doing slicing, okay. And we have the mass properties, total mass, or else you can take your file which you already entered each and everything in that program script file. You can select that and can accept, okay. uh, know if you have missed these parameters or this total mass. Okay, then you can just type like your second moment of inertia value for x axis, y axis, z axis. Okay, single lever CG. Okay, and other parameters. And here we, yeah, so you can compute up to that. And also we have projected area option. By using this menu bar, you can get the projected area of your model. Okay, so now currently I have not added any model. Okay, same here, you can even select the script file and you can start your execution. So once you select your file and once you type the start button, so your file will execute to give the projected area for your respective file. Okay, which means you'll get result, and that area will be displayed here in this checkbox what we have. Okay, yeah. So next we have surface interaction. In the surface interaction we have global, display, and output. Okay, so all these options you can use to show the points, to show the curves, to show the border curves of your uh, model or of your script file. Okay, so whichever you need you just select, and whichever you don't need just you unselect this checkbox. That's it. Okay, it will work for that case. And you can intersect and report. Here in this output you can export your raw point. Okay, and if you have any file which you want to export which is in dot curve format and also dot p3d format, that you can select and you can intersect and also you can export. Okay, so this is all about surface interaction. And also we have CFD mesh. Okay, in this CFD mesh we have the global, in this global maximum edge length, how much you want to keep for your model. You can alter. Okay, global mesh size. Okay, maximum length, minimum edge length, maximum gap, how much you want to keep. Okay, before doing CFD, the global mesh control points you can give by using this tab what we have. Okay, and number of circle segments, growth ratio. So yes, if you are well known with your uh, analysis theoretical points or theoretical concepts, then you will give your values according to your requirement, right? So no doubt with that. So that's why for to do analysis or to go for any analysis, okay, for any kind of model, we must know the fundamentals. Okay, theory concept or fundamentals of that analysis part is very important, like our continuity equation, momentum equation, energy equation, and other parameters which will be encountered. Okay, during this CFD mesh. Okay, okay, whether like for high fidelity options in the see our ANSYS fluent will use no. Okay, our options like k omega, okay, k epsilon. So like that we have in this high fidelity, in that high fidelity here you will not uh, have that of time wasting parameters. Okay, just you can give your boundary conditions as per your requirement. But in just short period of time you can analyze your model. That's the advantage of open VSP analysis menu bar what we have. Okay, and in the display you can off this checkbox if you don't want to show your mesh. Okay, and if you don't want to show your color tags, that also you can off. Okay, once your mesh is displayed, suppose if your mesh is done, and if you are displaying in this VSP window what we have, this is our VSP window. Okay, if you want to off your mesh of that geometry, or what geometry if you have, suppose I will take one one component. Let's say this is our one component fuselage. Okay, okay, so for this fuselage suppose I have done the meshing. So now if you don't want to show the mesh, you can off, and you can just see the geometrical view. That's it. Okay, and rest other what we have the same. Okay, same option, it will play same method. Like if you don't want, then just off your checkbox, then you can't able to see in your open VSP. If you want, then just on that checkbox. So mesh related parameters what we have, it will display once you on the checkbox. If you off the checkbox, it will undisplay. That's it. Okay, which means we can't able to see in this VSP window. And also we have the interactions curve display. Okay, this all respect to the curve displays interactions for our any model. Okay, if you want to interact your curves, or want to show interaction curves, or want to show the border curves, or want to show the curve and points. So for that case, we have this all options, and also we have the output. In this output, okay, here we have export file. Once suppose you have done complete from initial to ending, which means here in the open VSP itself you have done the model, in the open VSP itself you have done the analysis. Now you want to export to other file, you can export, okay, in .stl format, or you can even export your file name in other format what we have. So this tab what we have is like export file names, and we have sources. Okay, this part I will tell when we will come to any one model analysis. That time I will tell. And domain. Okay, just this is all about domain. Once you have the model, any meshed model or meshed model, that time you can able to see this checkbox domain, complete domain, and we have wakes, number of wakes, and number of scale. Okay, wake scale and wake angle. If you want to increase, you can increase. Okay, so this is uh, for scale wake, that is 5 unit, and wake angle 2. Okay, degree. So you can change that. Once you done with this, then you can run your file. I mean, like you can mesh and you can export. Yeah. So we have FA mesh. So finite element mesh also can be done. Okay, by adding the part name and material, which type of material you want to add. Okay, to complete your FEM FEM method for your respective model. Okay, so aluminium, titanium, or other material. Okay, you can even add the material if you know the mass, density, and elasticity modulus, Poisson ratio, and other parameter of your model. Just add, and you just accept. Okay, or else you can the material which you added you can even delete. Okay, and also we have properties and mesh. Okay, maximum edge length and all. Same, this is like a output, the file export. In all this form, you can export your file. In this display, you can display your model. Okay, mesh model. In this analysis, CFD mesh tab is completely different, and our FEM mesh tab is completely different. Okay, and we have VSP arrow. In the VSP arrow, suppose once you added your model, okay, once you done your model in the VSP tab here, so after that you go for analysis. Okay, you can use the launch solver or launch views. Okay, so once you solve your model, then it will take time to launch. Okay, 1, 2, or 3 minutes based on your model size and length. And after that you can able to see the parameters. Okay, I mean, like, which parameter you want. Like if you have a wing, then you want lift parameter or drag parameter or zero drag coefficient, so that you can generate. Okay, and we have VSP arrow, wave drag. Okay, so for your respective model you can even generate a wave drag, and you can plot, and you can just click on the start. If you click on the start, you'll get the graph. Okay, so this graph that we have, this is our wave drag graph. Okay, for this model, see, I have not done anything, just automatically it took, right? Just I have clicked. Okay, it's just a rough model. So like that you can get all this information, parasitic drag and other aerodynamic parameters for your respective model. Okay, so I'll stop here. This is all about analysis introduction class, and we'll go in a deep. Okay, so for today, this much is okay. So thank you. We'll stop here. We'll continue in the next class.
Okay, thank you, sir.